everybody.
Good
Good
morning.
We're the UT Austin Physics Circus. My name is Natalie, and this is my friend Joey. And we are graduate students at the University of Texas at Austin in the physics department. And today we have some very exciting demos to show you about the science of germs. So what can you think of that germs has to do with physics? Well, if you stick around, then maybe you'll make some sense of it and kind of connect that part of your world to something unknown like physics. So we want to make sure that you can see physics as a knowable place and something that you can question and learn some things about as well. And we're going to have some fun. So in this day and age, you know, we're all kind of getting used to this pandemic situation and getting used to dealing with germs on a daily basis, you know, maybe more than usual.
Yeah.
So we're going to talk a little bit about that. And maybe you can learn with us together, learn together with us about what we can do to help the spread of the pandemic slow down and how science teaches us about what is appropriate in terms of slowing down something like the coronavirus.
Yeah, and remember always that ask questions. It's a scientist's job to ask questions, and you guys are scientists just like us. So make sure to ask a lot of questions, be curious about a lot of things, and if you have questions, make sure to put them in the chat there. So what is illness? When was the last time you got sick?
Oh, I haven't been sick in a while. You know, I've been staying at home most of the time and only being around a few people at a time with my mask on. So I've been pretty healthy for the past year and a half or so.
Yeah, nice. Yeah, I think I felt a little down this morning, but it just went away. So I'm happy about that. But yeah, make sure to stay at home and stay safe. And so when you're sick, what happens is tiny little microbes, these little invaders, they get into your body somehow, and they mess with your cells inside your body, and they cause it to do bad things, make a lot of different viruses and things like that can hurt you, and that's why you end up feeling sick, because there's tiny little invaders that get into your body and make you feel sick. So
yeah, so they're kind of like hanging out inside your body and trying to make it like their home.
Yes.
And that our body as the host isn't really kind to those kind of visitors.
Yeah,
so,
it doesn't like unwelcome visitors.
You know, you might feel like a fever or like a scratchy throat
or really
something.
sleepy sometimes.
Yeah. So what is that? What is that kind of response?
So that's your body trying to fight off the invaders. It might heat itself up because the invaders don't like really hot places. So your body heats up. That's kind of why fevers work like that too. And when you sleeping has a lot of tremendous benefits. So when you sleep, your body kind of goes into a recovery mode and then it heals itself. So that's always really good to have. But another thing is understanding how these viruses spread. So these germs and these bad viruses can enter like mucuses, so they can enter your ears, they can enter your nose, your mouth, your eyes, a lot of different pores on your skin. So it's important to try and stop them from entering these places so you don't get sick.
Yeah. So what does it kind of look like when an illness spreads? When we sneeze or something. Yeah.
So a lot of times there's, if you might not know, there's germs everywhere. There's germs on this table, on this paper, on you, on this backboard back here with these wonderful equations. They're everywhere. So we have to try and understand how they travel and how they get to places. So if I touch this, I might pick up some germs from here. If I touch this, I can pick up germs from different places. So the more things I touch, the more germs and stuff that my body and my hands pick up. That's why your hands are often, you have to wash them a lot. So yeah, it's not just touching though that can do this. It's also breathing. When you breathe in and out, there's little germs floating on the gases in the air that we learned about last time. So they hang out on the gas, they hang out in water floating around, and you can breathe them in, you can breathe them out, So you can also spread them out through just breathing. So
Oh, really?
yeah.
Yeah. So what, if we try to keep our fluids to ourselves, maybe we can prevent it from spreading to our friends and our family and people around us. I wonder what that might look like.
Yeah. So one common thing that happens when you spread disease is when you sneeze, you release a lot of fluids. So I bet you felt that it's not very fun. So we'll kind of demonstrate that here. We'll use this fluorescent paint. So I'm going to dip some of it on my finger here, and just imagine that I sneeze. I can get it all over my hands, right? When you sneeze, if you don't cover it, some good ways to cover it are if you sneeze, make sure you sneeze into your elbow, or if you have something here like a tissue, sneeze into the tissue, make sure you wrap it up and throw it away. You don't want anyone to catch those germs. So that's what happens when you sneeze and you don't cover it up. The germs go everywhere. So just remember to sneeze into your elbow or sneeze into a tissue to stop the spread of germs.
Yeah. So throughout this show, we are going to demonstrate how from one source of this fluorescent paint from my friend Joey, we're going to spread it throughout this table. So for example, right now you might not see too many germs here on our table. My hands are pretty clean. Joey's hands are already dirty.
I sneezed here. So this is the paint that's gonna be kind of go around. Now we're not gonna try and touch each other and high five and stuff, but we're just gonna be handling the stuff here.
Just by touching the items here on our table, we can show you how this is spreading. This illness might be spreading with all the items that we're sharing.
Yeah.
Not necessarily just between us two. So we'll show you at the end of the show what that might look like. Okay? Okay, so why do we wear this mask, and why is that even important?
I wore it today because I didn't brush my teeth this morning, so my breath smells kind of bad.
Okay, well, in normal pandemic times, I guess or non-pandemic times, that might be one reason why you wear a mask. Nowadays, we wear a mask to keep those fluids inside, and so we don't spread them throughout the air. But I'm wondering, why are masks effective? And you might be wondering the same thing too. So we're going to demonstrate with different items here. We have a brand new bandana from the store, and we also have a KN95 mask, and then just our regular mask here. So we'll show you kind of visually what it looks like to have the mask on and how it might prevent us from spreading some illness. Okay, so first I'll demonstrate. I'm going to light this little candle here. Okay. You see that? Okay. So let's just pretend that I'm wearing no mask at all. I won't do that, but you can imagine that you would blow out this candle very easily. But what if I wore just this bandana here? So it's brand new, and it's clean, and I'm just going to demonstrate what a thin material might look like.
Huh.
So
it seems like there wasn't a lot of material, so it didn't stop your breath, right?
yeah, it looks like maybe this is really, really thin.
Yeah.
Whereas, I think that this mask is probably a little bit better than this bandana. Or you can also try a KN95 mask. So let's try it again.
Try it again.
Hopefully the mask I'm wearing is good enough for this. So I'll try to blow out the candle once more.
Huh.
You can see that the candle didn't blow out this time.
Yeah.
Right? Because this mask is a triple layer mask. It's cloth mask, and you might be using something similar, maybe like a surgical mask is also triple or quadruple layer, and those work just as well. And KN95 masks work the best, but I won't demonstrate because we already have a good enough mask here. But these are also very good. So why does that work? Well, masks are made out of tiny, like a mesh. Now we can blow that out.
There.
We don't want the sprinkler system to go off here. So masks are made out of like cloth, which is, if you look at it microscopically, it's like a mesh. And in order to be able to contain droplets of coronavirus particles or any kind of germs, they need to be at least small enough to not allow about 300 nanometers in size. So a coronavirus particle is about 300 nanometers. And to put that into perspective, if you took a human hair and you expanded it to the size of a football field, a coronavirus particle wouldn't even be out to the 1 yard line. That's how small these things are. So in order to be able to block out these coronavirus attackers and germs, anything like that, they have to be able to be caught in this net, right? So the thing is, this net is obviously too thin to contain droplets of your breath or anything, but you can still breathe through it because oxygen molecules are smaller than that.
Really small. Yeah. So if you can, kind of think of the mask like as a net here, and then the coronavirus one here would be about 300 nanometers. The oxygen molecules would be a lot smaller, so they can pass through. So if you have like a triple layer mask or an N95, it's just going like, it's having more layers, and the layers are smaller.
Right.
So then it doesn't allow a lot of things through. So then it'll block the viruses, but then the oxygen can still go through.
So you'll still be allowed to breathe normally with the added benefit that you're not spreading any kind of germs around your environment.
Yeah.
So why don't we give that a try with these colanders and different size particles?
Yeah. So here we have 3 different things. We have some sugar. We have some nice pasta. We might cook with it later, maybe not. It's kind of been here a while. And some rice. So what might be the properties that lets it go through? Say for example, this colander here is the mask we have on. What kind of properties?
Well, I guess it might be the size of the mesh and the size of the particles. So you can see we have 3 different sizes of particles here, the sugar granules and the rice, and then a large pasta, a big rigatoni.
Yeah, so let's try it with the big one first. Let's see how that does.
Yeah, let's see how it would block something large. Okay. We got nothing.
Just a pasta stuck here. Okay.
So what does that mean?
So that means those were too big to pass through the holes here. So that's pretty cool.
That means that, if you have a particle that's this big, like a large coronavirus particle and a small mesh in a mask, we can stop it with the right type of mask.
Yeah. So let's try it with a smaller one. Here, we're doing rice right now. So if we pour the rice in.
All right. Looks like maybe some of them are getting through. Why does that happen? Looks like we got some passed through, so it wasn't entirely effective. Can you see this here? So
it looks like the rice it's kind of long, so it might not pass through it all the times, but sometimes you get little short pieces, or maybe it goes in kind of vertically and it passes through the holes. So there's some chance of it passing through.
Right. So there are some kind of masks. When you read a mask, the properties of it, and it says it's 95% effective or something, that just means that it's taking 95% of these rice granules and keeping them out of the red bowl, which might be, it might be your face, or it might be the opposite. It depends on which way you're breathing the particles.
Yeah.
Now, if we try, go ahead. Okay. Now, if we try a really small granule particle like sugar, I'm just going to pour a little bit in here because it's all going to go through. So if you've ever used sugar, you know that it's pretty small compared to rice or pasta or anything. So
Yeah. So
you can see that all of it went through.
yeah.
And that might mean that could be the oxygen molecules that are passing through your mask are able to pass through unimpeded.
Yeah.
So it's really important to have the right type of mesh in your mask.
Yeah. So if this is our mask, we can think of these as bigger particles, kind of like viruses and things.
Yeah.
These the rice might be some smaller viruses that still get blocked through, like a lot of times, 95%.
Mm-hmm.
And then these smaller sugar, you can think of as oxygen. So all of that goes through, you can breathe just fine, but it works to protect those around you and yourself from getting viruses.
Right. So just keep that in mind next time you're wondering, what's so important about triple layer mask? What's so important about wearing a cloth mask versus a bandana, for example, or no mask? No mask just means it's totally open. So that's always important to consider. In this next demo, it's something that you can follow along with us at home if you have the items that we'll show you here. So you'll need some ground black pepper, and you'll need a cotton swab. You'll need a white plate. It can be paper or styrofoam or china, it doesn't matter. And we also have some water in a kettle. You can use your faucet and some soap, some detergent here. So if you have all these items, you can follow along with us, or you can check out our YouTube channel. We also have it recorded there for later. So this is going to demonstrate kind of how soap interacts with germs and why we wash our hands. Okay, so first we're going to just pour some water in this plate. Okay, nothing special about that. And then we're going to take some of this ground black pepper. You can use like any ground spice you want.
Yeah.
Doesn't really matter. But you can just sprinkle a little bit of pepper on the surface, and as you can see, can you see that pretty well? It's all just hanging out on the surface of the water here. Okay, so these ground black peppers are representing like germ particles that might be on your hands, which are on your hands. They're always on your hands. So if we just take a Q-tip and dip it in the water, what do you think is going to happen? Who knows, right? Let's just see what happens. That was so boring. Nothing really happened because there's nothing on the surface of this cotton. Okay? So what we're going to do is now we're going to employ the soap. And we're going to use, you don't need this much detergent, but you can just dab a little bit on the top of your Q-tip, like so. And now think about what might happen, okay, when I place this Q-tip in contact with the soap, or with the water surface.
Whoa!
Whoa! Did you see that? Cool. So we saw that the soap, when it came into contact with the pepper, what happened?
It just ran away.
It looks like it pushed the pepper away almost. So what's happening is the soap is it's a type of substance that likes to break up water surface tension. So that's your physics word of the day, is surface tension. You might see it when there's like little bugs hanging out on the surface of a pond or something. And if you drop water on like a penny or something, that's another common one. You can see the surface of the water is kind of curved.
Yeah, or sometimes when you fill up cups, sometimes you see it kind of bulge at the top. So that's surface tension as well, keeping the water together.
Yeah, and surface tension happens because water molecules, they really like each other. They're really good friends with each other, and they just like to hang out. But when you put in something foreign, specifically this soap, those
breaks it.
It's like breaking up a party. You know, the soap comes in and says, "Hey, get out of here!
Stop it! Get out!"
And because the pepper is on the surface of the water, it kind of shows us how the water surface is breaking up. So when you wash your hands, the soap pushes away germs on your hands and rinses them down the drain. So it's really important to wash your hands with soap and water.
Yeah. So how long should I wash my hands for the viruses and stuff to die out?
I think about the time it takes to sing the quadratic formula 3 times.
Okay, so x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And then sing it twice more. Or you can sing happy birthday twice.
Yeah,
you can sing the alphabet twice. Whichever you want. My favorite one, our favorite one, is definitely the quadratic formula.
We love the quadratic formula because it reminds us of math. Whatever. So you can pick whatever thing you like, but wash your hands at least 20 seconds.
Yeah.
So, all right. Another thing that might give you a reminder of what surface tension is something like bubbles, right? Bubbles, they literally only exist because of surface tension.
Yeah.
They're perfect spheres floating around, and this film of soap, once it gets popped like that, you're breaking the surface tension. Well, there's a little, and it's actually just like completely disintegrating the bubble.
Yeah.
So that's another kind of visual of what surface tension is. It's just water molecules liking each other, or these bubble. They like to be together.
Yeah. So when I poke it, it breaks the surface tension, and the bubble no longer exists because it exists only because of surface tension.
Only because of surface tension.
Okay.
So that's an important concept. Okay, so we're at the end of our show now. So let's see how far our germs have traveled. We'll actually turn off the lights so you can see it better.
Yeah. So remember, we didn't touch hands. We didn't high five. We tried to just didn't touch the same thing. We touched different things, handed them to each other. So let's see how much our germs have spread.
Let's see on these items here. Whoa. Look at that. That's so nasty.
Oh,
we got germs all over the place.
Oh, whoa.
Yeah, look at that. We got it a little bit on here. That's pretty nasty. Did we get any over here? Oh, yeah, totally.
Ooh.
So you can see that just a little bit of that.
Yeah. And
germs can just carry on.
Yeah. And I was the one who sneezed, so I wasn't touching stuff over there, but the germs got over there somehow. So
you touched something that I touched, and I
Yeah.
carried over here. So, you know, we've already shared so many germs just in a few 20, 25 minutes here.
yeah.
I'm gonna definitely wash my hands when I get home. So.
And I'm gonna brush my teeth as well.
So thank you for tuning in today, and we'll let you get out to the rest of your Girl Day activities. But please, if you have any questions, feel free to drop them in the chat, and we'll stick around for a few minutes, and we can answer any questions that you might have. Yeah. What's your favorite kind of soap? I love Mrs. Meyer's soap. It's like, smells so good.
Oh, I don't know. I think Dove.
Dove is pretty good.
Dove. I like the lavender.
Yeah.
Lavender scent.
Aromatherapy.
Yeah. Sometimes I smell my hands afterwards just because it
Yeah,
smells so good.
I know. It's great.
Or the honey. There's like a honey cinnamon.
Nice. Yeah.
Ooh,
I wonder if they're any more effective because of the honey.
because of the smell.
Something that smells good. Yeah. I always learned, like, when you wash your hands and they get kind of like bubbly, I always thought that meant, like it's really washing them. But I read somewhere that it doesn't really matter as long as like the frothiness doesn't do anything. But as we saw here, there was no frothiness and it still worked. So
If there are germs everywhere, aren't there germs in the water and soap we use to wash our hands? So it'll spread more germs, not less, right?
Oh, that's a very good question. So germs, they're pretty much on every surface, but on liquid surfaces like water or in soap and stuff, they typically will just get washed away. So it's kind of like if you can think of a waterfall clearing out like debris from a storm or something. It just washes away. And it might still float on the water, it's true, but it'll be down the drain or something. So the thing is that germs aren't always a bad thing. Bacteria is actually makes up most of our bodies, actually. It's just the quantity and the type of germs.
Mm-hmm. Yeah, and another thing too is soap. Its job, like me poking a soap bubble, its job is to break up surface tension. So when you wash your hands with soap, the bacteria and the germs there, the soap acts to poke it and essentially pokes it and then makes the germs explode and break up their kind of cell membrane that acts like the bubble. So the soap's job is to poke it until it explodes, and then that's what kills the germs.
Get it out of here.
Mm-hmm.
Yeah.
How come we can't do the pepper experiment twice with the same water if we add more pepper?
Right, that's a very good question too. So in order to redo the experiment, I would guess that you would have to pour some fresh water because the surface tension of the water has already been broken. That top layer of the water is already kind of messed up, and those water molecules they're already spread out as much. So there are still water molecules there, but they might not be as coherent or as sticking together as closely as they used to.
Yeah,
right?
yeah, and another way to think about it too is when you first pour it and put the pepper on, it's kind of like a balloon. And when we poke it with the soap, we poke it with a really sharp thing, and then the balloon kind of pops and spreads out. So we can't do it again because the balloon already popped. So we need another to pour it again to essentially make another balloon.
It's kind of like
layer.
refilling the balloon.
Yeah.
The balloon is still there, it's just popped.
Yeah.
That's a good analogy. Yeah.
So does soap kill germs or make them weaker?
Do you know the answer to that question?
Mm,
Some soaps, so this is just dishwashing liquid, but I know some soap at my house that has like antibacterial, and bacteria are not viruses, but they are a type of, could be an invader. Bacteria are not always bad, but they can cause some things to go wrong. So it depends on the kind of soap.
yeah, and if you look at like germax, you can see sometimes it says 99.9% effective. That means it kills out 99.9% of the kind of germs that are in there. So the germax in the soap, its job again is to poke the germs and poke the cells until their outer layers is destroyed, and essentially they can't live anymore without that protection.
Yeah. Well, I guess hand sanitizer too, when it has that strong smelling alcohol, that I think actually kills the germs.
Yeah.
And we're not biologists, but or epidemiologists or whatever. But I think that certain types of compounds can actually kill germs and bacteria, and not just simply wash them away.
And that ties into Haley's other question, which is how does germax work?
Oh yeah, that's a good question. We didn't bring any germax here, but it's got some kind of alcohol that instead of washing away germs, it kills them, and then it dries up on your hands. So maybe you just have a lot of dead germs on your hands.
Yeah, I don't know.
I'm not sure. That's a good question.
Yeah.
Really. Okay. So it looks like it's about time to wrap up so that you guys can get to the rest of your Girl Day activities. So we'll end here, but thanks for joining me and Joey, and we hope you have a wonderful scientific rest of your weekend.
Yeah, and keep asking questions because that's what makes a scientist.
Great. Bye, guys.
Bye.